Okay. Today we are going to discuss the Arrhenius theory of ionization. Okay. Before we get into detail of this theory, first of all, let us try to understand what is ionization process. Ionization process is the process in which the neutral electrolyte gets ionized into ions. Neutral electrolyte gets ionized or undergoes a process in which the ions are formed. That process is known as ionization. The ionization of that compound can be undertaken by various ways. One of the ways is dissolution of electrolyte, dissolution of neutral electrolyte. Whenever I say a neutral electrolyte, that means it doesn't possess any charge, either positive charge or any negative charge. Okay. In the year 1884, the scientist Arrhenius has performed many experiments in which he measured the conductivity of different electrolytic solutions. What he did, he performed many experiments by which he measured the conductivity of different electrolytic solutions, and finally, eventually, he came to the conclusion that the conductivity of any electrolytic solution that depends upon the number of, or that depends upon the presence of ions in that solution. Okay, if the electrolyte does not produces the ions upon dissolution, that electrolytic solution does not conduct the electricity. That does not conduct the electricity. Means after performing so many experiments and studying the conductance of the electrolytic solutions, he came to the conclusion that the conductivity of the electrolytic solution is due to the presence of ions. That ions may be positive or negatively charged, and the Arrhenius in 1884 he put forward the theory called Arrhenius theory of ionization. Arrhenius theory of ionization, and he during the by forwarding this theory, he pointed out some important points that are considered to be the points of Arrhenius theory of ionization. Let us discuss these points one by one in detail. Let us discuss each point which was mentioned by Arrhenius in his theory of ionization in detail. Okay. The very first point he observed during these experiments that when an electrolyte having neutral charge, or when an neutral electrolyte is dissolved in a proper solvent, per se water, when a neutral electrolyte means it has no charge. That electrolyte has no charge. Such electrolytes, for example, AB. Let us take a general example of an electrolyte is AB, where this molecule or this electrolyte does not possess any charge. Okay, such electrolytes are called neutral electrolytes. When such a neutral electrolytes are dissolved in a proper solvent, okay, when such electrolytes which are neutral in nature dissolved in a solvent, they produces the ions with certain charges. Okay, means when this neutral AB is dissolved in water, it undergoes ionization and forms A plus and B minus ions. this neutral electrolyte gets dissociated and forms A plus and B minus, or in simple words I would say AB undergoes dissociation and form charged particles, and Arrhenius called the charged particles. Arrhenius named the charged particles as positively charged ions are called cations. Positively charged ion in the solution is called cation, and negatively charged ion in the solution is called anion. Okay, cation and anion. Okay, during his experiments for the study, which were performed for the study of conduction of electrolytic solution, he pointed out some important things, and these things mentioned in his theory. And one of the things that he pointed out, that whenever neutral electrolyte water undergoes dissociation and forms charged particles, positively charged ion is called cation, negatively charged ion is called anion. Okay, now like for example, when AB is in the solvent, when AB is in a proper solvent or water, it undergoes A plus B minus ion. Okay, one electrolyte dissociated into A plus B minus ion. This positively charged ion is called A plus is called cation and B minus is called anion. According to the old theory or old form of this Arrhenius theory. Later upon, after few years, again that the scientist Arrhenius observed that by various experiments, he observed that neutral electrolyte, which was taken as AB, okay, that neutral electrolyte, we cannot say that is a neutral, because though it is neutral in nature, but ions are present in its solid state also. Okay, after progressing various studies, he concluded later upon, after this theory, this was the old form of Arrhenius theory. According to old form of Arrhenius theory, okay, neutral electrolyte forms ions, but later on, after advanced studies, it was considered that this AB solid state molecule has itself consists of ions. Though it is a neutral, since the positive and negatively charged ions are equal in number, therefore the electrolyte is said to be neutral. But in the old theory, it was suggested that upon only dissolution it produces ions, but later on it was said that though the electrolyte in solid state, it possesses ions. Okay, only the difference is these ions are held together with an electrostatic force of attraction. Okay, in the solid state of an electrolyte itself, ions are present, only they are held together tightly with the electrostatic force of attraction. Okay, now, and upon dissolution of such an electrolyte, which consists of ions, but they are held together with each other, upon dissolution, only the ions get separated from each other. Okay, old form was telling that neutral electrolyte dissociates into ions, but modern form of this theory suggests that electrolyte consists of the ions, but they are held together with each other with the electrostatic force of attraction. Only upon dissolution, this force of attraction gets weakened, and the ions get separated from each other. Means in both form, it is said that in both form the ions are formed. Ions are formed, and positively charged ions are called cations, negatively charged ions are called anions. This was the first point, this was the first observation that was made by the scientist Arrhenius. Secondly, the second observation of Arrhenius during his experiment is the ions present in the solution are constantly unite. Okay, as the ions are formed, A plus plus B minus, as the ions are formed, again when these two ions, oppositely charged ions, come closer to each other at such a distance that they combine, reunion takes place and they convert into neutral electrolyte. Okay, as soon as the neutral electrolytes added into the water, it forms A plus and B minus ions. But when these two ions again combine together to form a neutral AB, therefore it is said that there exists an equilibrium between ionized particles and unionized or neutral particles. Okay, there exists an equilibrium. Equilibrium means what? The state at which the number of products and number of reactant becomes equal. That state is called as equilibrium state, or the rate of formation of ions and the rate of formation of neutral electrolyte becomes equal. That state is called as state of equilibrium. Okay, as soon as the ions are formed, again they recombine with each other and form neutral AB. The process of formation of ions and formation of neutral ion taking place simultaneously, and there, that is why it is said that there exists a state of equilibrium. State of equilibrium means this forward reaction and backward reaction taking place simultaneously with the same speed. That state is called as equilibrium state. Okay. Now, if to the equilibrium state, when the reaction is at equilibrium state, when the ionization is at equilibrium state, if we apply the law of mass action, law of mass action means the dissociation constant of this reaction is equal to the ratio of product divided by ratio of reactant. Okay, or in simple words, I would express this law by applying the law of mass action to this ionization process. I can write it that K is equal to concentration of A plus ions into concentration of B minus ions divided by concentration of AB. Okay, here in the forward reaction, A and B ions are product molecules and AB is a reactant molecule. Therefore, it is the ratio of product molecules to the reactant molecule. And here K is called proportionality constant, or it is a dissociation constant. Dissociation where K is called a dissociation constant. Okay, now this was the second observation which was made by the Arrhenius during his experiments. Now let us discuss the third observation or the third point which was mentioned by Arrhenius in his theory of ionization. And third point, that is, I would say it is a very important. These charged particles are now, okay, electrolyte is dissolved in a solvent, ions are formed. Now these charged particles means cations and anions, now they are free to move anywhere in the solution. Or to be more precise, I would say as soon as the ions are formed, they are free to move towards their oppositely charged electrodes. Okay, we know that in the electrolytic cell, okay, there are two electrodes. There are two electrodes which are connected externally through a wire. Okay, one electrode is cathode and another electrode is said to be anode. Cathode is negatively charged and anode is positively charged. Okay, into such a electrolytic cell, okay, suppose there are cations and there are anions. Okay, now this cations means positively charged ions, they move towards the cathode and anions move towards the anode. Okay, wherever the cations are present in the solution, okay, in the occupied space, they try to move, or they move towards the positively charged ions moves towards negatively charged electrode. Positively charged means cations moves toward cathode, anion moves towards anode, and during this movement of the ions, the electric current flows, or this movement of charged particles towards the respective electrode explains the conductivity of electrolytes as well as the phenomena of electrolysis. Okay, I think this portion, this third point we have also discussed in the process of electrolysis, how the electrolysis process is carried out in, how is the electrolysis process is carried out in a electrolytic cell. That part already discussed in detail. But the third observation of Arrhenius theory was the charged particles in the solution after dissociation, they are free to move in the solution, and as they are free to move because of the less electrostatic force of attraction between the positive and negative charged ions, they are free to move towards the respective electrode. Respective electrodes means positively charged ions moves toward negatively charged electrode, and negatively charged ions move towards positively charged electrode. Cations towards cathode, anions towards anode, and as a result of movement of these ions towards the respective electrode, that solution conducts the electricity. And hence it is explained the conductivity of the electrolytes as well as the phenomena of electrolysis. Okay, third point of this theory explains the phenomena of electrolysis, and the fourth point of this theory, or I would say the next observation of Arrhenius in this theory of ionization is given as, now the conductivity of an electrolytic solution depends upon, he has studied many experiments, he has performed various experiments and studied the conductivity of different electrolytic solutions. Then after studying so many experiments, he again came to one more conclusion, and that is nothing but the conductivity of an any electrolytic solution, not a particular solution. Conductivity of any electrolytic solution depends on the number of ions, number of positively or negatively charged, number of ions formed during the electrolysis process. Okay, the conductivity of any electrolytic solution, it is depends upon the number of ions present in the solution, the degree of dissociation. Therefore, he concluded that electrolytic conductivity depends upon the number of ions present in the solution, and number of ions present in the solution, that depends upon the degree of dissociation of neutral electrolyte. Degree of dissociation is the extent to which that electrolyte undergoes dissociation and forms ions. The extent of dissociation of electrolyte into ion is known as degree of dissociation. Degree of dissociation. Fourth point is, as the conductivity of electrolytic solution depends upon the number of ions present in the solution, thus the degree of dissociation of